this is what I came up with for motor mounts. Unfortunately, the motor mounts that were sent by Omniturn are not going to work. Rich over at Omniturn told me as much. I think these are for the GT machine, and I'm pretty sure that these are for a machine upgrade that has the sheave drive or shiv drive system, which this machine didn't have. So this is the area where the pulley and the new belt are going to run. So there's really just no good way to mount the motor over here. You know, there's these hollows in the casting and things that are a different height than these mounting pads. So I did bring the level of the pads up with shims, and I made a couple of motor mounts out of iron. I slotted the motor mounts so that I can bolt these directly to the table, and the idea is that once the motor is bolted down, I have a little bit of adjustment here to get my pulley and my belt in the exact right location, lock this down, and then I can mount the motor down to the plate like so. And when these are locked, I can always take the motor off if it ever needs to come off for whatever reason, rebuild it, you know, I don't know, whatever reason. You can take the motor off and then retain the location for the belt and the pulley. And then with these, I just welded, basically I threaded the plate, threaded a bolt into the plate, bolted them to the bottom of the motor so that they were, you know, held in exactly the right orientation and spot. And then I just put a quick weld on the bottom. So that's the idea, and we'll see how that works. So here's my current predicament. I have the motor mocked up on the motor plate. I have the motor plate adjusted pretty much all the way down. In the rear, I got about maybe 3/4 of an inch that I could go down, but the belt still too loose. The smaller belt, the shortest belt, is actually too short by a little bit when I adjust the motor plate all the way up. So trying to decide what to do here. I think I'm going to move the mounts all the way up, put the shortest belt in, and make some standoffs that I can put on the plate right here, such that I can move the motor up maybe another inch or two, however much I need. But I'm going to mock it up the other way, and yeah, I'm going to mock it up the other way and see where we end up. So I adjusted the plate mounts all the way back up in the front and the rear. I put the short belt in, and absolutely didn't have enough room. So I added, oh, I don't know, maybe an inch to the top of my little motor mount bolts, and that just gets the belt on the pulley. So I think I'm going to end up making some approximately 2-inch standoffs, and I don't know, I need to think about this for a minute, but that's where I'm leaning now. Alright, so here's where we are now. I built some, I guess you could call them standoffs, brackets, out of C-channel. Raised it up about 3 inches, raised the motor up about 3 inches, and we're in pretty good shape with the belt. You have plenty of adjustment, and I think it's going to work out fine. Some 2.5 inch, 2 1/4, 2.5 inch C would have been ideal. All I had was this 3. After everything proves that it's going to work out, I'll probably weld, put a few beads here and there, and weld the C to the bottom brackets. But it's solid. It's not going anywhere. Okay, the next order of business is to drill the small end of the motor shaft for a pin that will interact with the encoder that's going to sit on the end of the motor here. And I made a bushing to do the drilling with. Just now getting set up, and unfortunately I can't get any better than about 1.5 thou, no matter where I measure on this shaft. The best I get is about 1.5 thou. The directions call for the pin to run within 1/2 thou, and it says that you tap the pin once it's installed to get it to run within 1.5 thou. But the bushing that I made, no matter how concentric it is, it's at least going to be 1.5 thou out. So that's going to be interesting. So let's see how it goes. These are the drilling and reaming bushings here. I made this collar. This collar is a nice fit on the end of the motor shaft here. As a matter of fact, my lathe turns a slight taper, and I use that to my advantage to get the bushing running true. And then the drill bushings are a nice slip fit, kind of tight with some drag, so that's good. That's exactly what I want. And with the drilling guide that I made on the shaft, with the drill bushing actually in the holder, the best I can do here is about 2/1000. Is that 1.5 thou? Alright, we'll call that 1/1000. That's not bad, considering there's 1.5 thou of play in that shaft to begin with. So I'm pretty happy with that. Let's get this thing drilled and see what we end up with. So even with all that careful making of bushings and drilling and reaming and being oh so careful, see if I get rid of the glare there, still have 6 thou of run out on that pin. So they want you to adjust that out by tapping the pin. Well, I'm going to give that a try and see how we do. Well, that's more like 7 thou, isn't it? Oh, that's disappointing. Well, it is what it is. Around, tapping this shaft around for about 10 or 15 minutes here. And I think I got it about as close as I'm going to be able to get it. They want 1/2 thou, less than 1/2 thou. And the best I can tell, I mean, this is a 1/2 thou indicator, and it's less than 1 division. I couldn't say how much, and you know, there's certainly some surface noise in that little pin too, but I'm going to call that good. Yeah, I think that's just under 1/2 thou. I also put in the pinhole, originally there was just a roll pin through this hole that retained the fan. Now that there's a shaft running through that hole, I can't put the roll pin through there, so I threaded that little hole, and I'm going to put some grub screws in there, some little 1024 grub screws. But I'm going to have to be careful. I'm going to use some blue Loctite. I don't want to put these down far enough that they influence the shaft at all. So I'm just going to put them in simply to retain the fan and not influence the shaft at all. That's it for now.